So we're going to look at the Dow Jones average, which is the average of several of the largest companies' stock prices in the country. Just a little bit of Googling brought me to fedprimerate.com. I don't know anything about this site, but I did double check a couple of the numbers on other sites, and it appears their data is accurate, even though I don't know anything about this particular website. And so what I found was that at the end of the year in 1982, the Dow Jones average was 1,046 and 54 cents. The end of the year in 2012, so 30 years later, it was 13,104 and 14 cents. Okay, so we want to know what percent is the Dow Jones average growing by on a yearly basis. We had 30 years in between here, and we started with this number and we ended up with this number. The Dow Jones average is updated at the end of the trading day every single day, so you might think of this as being compounded daily, but really it's changing all throughout the day as stocks are being traded all day long. And then there's weekends when there isn't trading, and so now it's not daily anymore. And so this is a weird one to think about what the compounding period might be. How often are we compounding our interest? So I want us to think about this as if it's continuous compounding, which again, it really isn't, because the Dow Jones doesn't get to change on Christmas or New Year's Day or Sundays, because there's no updating, there's no stock market trading on those days. But we'll consider this continuous compounding. And if it's continuous compounding, then we can use the equation P times e to the RT power equals A. P is our initial principal. A is where we end up after time goes on. E is our Euler's number, 2.718, etc., with all its decimals. R is our interest rate per some amount of time, and T is the time that has gone by. So if we wanted the interest rate per month, then T should be measured in months. If we want the interest rate per year, then T should be in years, etc. So let's see what that does with these numbers. This says our final amount, $13,104.14, is equal to our original amount, $1,046.54, times Euler's number, E, to the R, I don't know what R is, times T, time. If we put in a 30 here, that means R is going to be our percent per year that the Dow Jones has grown in the time that goes by. So that's fine. We'll just assume that R is a percent per year. Okay? So now I want to solve this. Well, one thing I can do to start things off is divide both sides by this 1,046.54. Which leaves us with just the exponential part, e to the 30r equals whatever this number is, and our calculator will tell us that. The calculator says 13,104.14 divided by 1,046.54 is 12.52, etc., etc. I'm going to store that number here because we want to remember what it is. I'll just call it A. So A is this fraction. And that is what e to the 30r needs to be equal to. So e to the something has to equal this number. Well, let's just try some numbers here. If I do e to the 1, obviously that's just e. That's 2.718, etc., etc. If I do e to the 2, that's 7.389. If we do e to the 3, that's 20.08. But remember, the number we were trying to get, that I stored in A, was 12.5. Hey, that's in between these two. Then that tells me the exponent I'm looking for should be between the 2 and the 3 that got me these two numbers. So we don't have any tools in our tool belt that let us solve to find out what r is because it's up in our exponent. Gosh, wouldn't it be great if we did? But for right now, we don't. So we're just going to continue to guess and check on this. This says r should be between 2 and 3. Well, so let's try 2.5. Ooh, that one's really close. It's supposed to be 12.52. I got 12.18. A little too low, so I'm going to bump up the exponent a little bit. About 2.6. That may be too much. Might not be enough. Yeah, that's too much. So we'll come back down. 2.55. I'm looking for 12.52. I got 12.80. I'm still a little too high up here, so we'll go 2.53. Oh gosh, remember what A was? A was 12.52. We're at 12.55. We're looking really good here. We could get even closer. 2.525. Oh, too low. So it's got to be between 2.525 and 2.53. How about 2.527? Here's A, 12.52, and we're looking at 12.515. That would round to there. We're getting awfully close, right? And we can keep zeroing in. Maybe e to the 2.5275. Yeah, now it's just a little too high, so we could change this 5 to a 3 or something like that. And we can keep getting closer and closer and closer. And so that looks like about where our exponent should be. So I'm going to go with this number, 2.5275. Is supposed to be equal to that 12.52 number. From guess and check, we found out that that exponent, which is supposed to be 30r, turns out to be about 2.5275. 2.5275. Then, if that's the exponent, which is 30 times r, we'll just divide by 30. 2.5275 divided by 30, and we get 0.08425. 0.08425. And R, remember, was our percent per year. This is 8.4% that the stock market goes up every year on average between these two dates. Guess and check is what allowed us to do that.